Hello, in this video we are going to take a look at payback and also at net present value analysis. Okay, let's start with payback. Let's assume that in year one we invested $52,000. It could be a piece of equipment or whatever it might be for the project. And in year two we needed to invest another $9,000. This is the amount of cash that I expect to have coming in each year. I expect to have $2,000 year one, $4,000 year two, etc. So based on that, how long will it take me to pay back my investment? So I'm going to go ahead and bring down my investment of $52,000 in year one and $9,000 in year two. Okay, my cash flows from year one are $2,000. So let's start there. If I invest $52,000 and I have $2,000 coming in, I put it to the side here. 52 minus 2 means I still have to recover another $50,000 from my investment. Okay, in year two, it says the cash flows are $4,000. Now, in year two, you still have $50,000 unrecovered from year one, plus you invested another $9,000 in year two, so that puts you at $59,000. Subtract $4,000 that you recovered or received in cash inflows, and I wrote it out to the side here. 50 plus 9 minus 4 means you still have to recover $55,000. Okay, in year three, your cash flows are $10,000. Okay, there's no more additional investments, so just take $55,000 minus the $10,000 you have coming in cash inflows, and you're down to $45,000. Year four, your cash flows are $11,000. 45 minus 11, you're down to $34,000. Year five, your cash inflows are $14,000. 34 minus 14 puts you down to $20,000. Okay. And year six, your cash inflows are $12,000. 20 minus 12 means you still have recovered investment of $8,000. Okay, now when you get down to year seven, cash inflows are expected to be $10,000, but you only need to recover $8,000. So of the $10,000 you expect to have coming in year seven, you only need $8,000 of it to recover your investment. So I put to the side, you only need 8 out of 10,000 after year six, or from that 10,000 year seven amount. So therefore, the recovery payback period is 6 years plus from year seven, I need 8,000 out of the 10,000 from year seven. So take 8,000 divided by 10,000 first. That gives you 0.8. So the payback period would be 6.8 years. Okay, let's go on to net present value. Net present value considers that as time goes on, money becomes worth less. I'm sure you've all heard of inflation. The cost of eggs or any type of food product has increasingly gone up, so your spending dollar doesn't go as far. Okay, let's assume our investment right at the beginning is a new machine that costs $39,000, but it's going to save us $9,000 a year. So we'll have additional cash inflows of $9,000 per year. Notice that's an equaling amount each year for the next 5 years. Now, at the end of year 5, there's no salvage value from that piece of machinery, and we want at least an 11% return. That means for every dollar we make, for every dollar we spend, we want to make at least 11 cents per year on it. Now, because value goes down, the value of money goes down as time goes on, we're going to be using two tables. And those two tables are available in the e-text, and they're also available in the module. I will be bringing them up here. The B1 table is for dollar, a single amount. The B2 table is for an annuity, when it's an equal amount each year. For this exercise, I'm going to use the annuity table because I expect to have an extra $9,000 each year coming in cash flows. But again, as time goes on, 5 years from now, that's going to be worth less than $9,000. So we have to determine what is that worth today. Well, first of all, we are buying that new machine today. So that means our cash flows will go down by its value today of $39,000. Now remember, we expect to have an increase of $9,000 in cash flows per year, but we don't take it times 5. We have to reduce that down, and we do that by going to the annuity table. So I'm going to bring that up now. We will look at 11%, our required return, and cross-reference with 5 periods for 5 years, the life of the machine. So our discount factor is 3.696. Okay, so I will go back to the problem. And what I'm going to do is take 9,000 times 3.696. And so the present value of it is worth $33,264. So to get the net present value, I'll take my cash outflow of $39,000 minus the present value of my cash inflow, $33,264. And I have a negative $5,736 because I do have more in cash outflows than I have in inflows. So a negative number represents we should not do the investment because we are not making at least an 11% return. If it was exactly 0, your decision would be indifferent. That is exactly an 11% return. Okay, question 2 then wants to know, what is the difference between the total undiscounted cash inflows, notice that undiscounted, not discounted, and the cash outflows? Okay, so the cash outflows would be the investment in the machine, $39,000. Now, the present value of the cash inflows is this $33,264. But if it's the undiscounted amount, we don't take into consideration the time value of money. We would just take $9,000 per year times 5 years for $45,000. Okay, so therefore the difference is $6,000. Okay, we'll go on to internal rate of returns in the next video. Thank you.